This is actually news I gave a few years ago, but I think it's worth a rerun. It's based mainly on a program, television program, with Jim Al-Khalili, The Secrets of SWHAS. And in the larger SWHAS, it's about the gravity and the movement of galaxies. So we start off with the cosmic microwave background, which was just 380,000 years after the start of the universe. And you can see how, well, you can't see from this, but it's a very constant echo with tiny variations. And those variations are shown here. And those tiny early variations led to the formation of the galaxies and the shape of the universe, basically. Okay. So today, our galaxy is surrounded by a number of local galaxies making up our local group. This group is dumbbell-shaped, in fact. There are a number of galaxies surrounding the Milky Way and a number more surrounding Andromeda. And the two arms are coming together, and in a few billion years they will merge. But that's our local group, which is gravitationally bound. It's not going anywhere. As we look 10 times further out, there's the Virgo supercluster, which we're part of, which we thought at that time, at the early time this was discovered, that that's pretty much the supercluster we belong to, but actually not quite. So the cosmic web of the universe is that the matter around us on much larger scales, things start to look strange. All the matter in the galaxies, along with our associated dark matter, seems to be arranged in filaments. So you get these areas of high density with large voids between them. It seems that galaxies are attracted to each other by gravity, quite understandably, and that has resulted in this pattern along with the dark matter throughout the visible universe. So everything I've talked about now is a static picture. A group in Hawaii and others have mapped the speed and direction of the galaxies. Here you can see the galaxies marked in red are moving away from us, and the ones in blue are moving towards us. So locally there are both blue and red galaxies. The further out you look, there is only red because of the nature of the expanding universe. We've known for years, many years, that the universe is expanding, and since 1999, I think it was, we know that expansion is actually accelerating with so-called dark energy. So now we have instruments a bit like Gaia, but looking further out, that can map the galaxies and their movements. And things are quite bizarre. The galaxies around us are all moving in one direction. How do we know what direction they're moving in? Well, when you look at the background radiation, it's always shown as like a constant in any direction you look, but actually it's skewed. We're moving faster with reference to that in one direction than another. So we know that us and all these galaxies around us are moving in relation to the general universe. So each one of these lines represents strings of galaxies moving along that line. It's difficult to imagine, but it seems that as well as being attracted by something distant, they're also influenced by the gravity of each other. So they seem to form these strings. So we now know that we're in fact part of a much larger supergroup named Laniakea, forgive my pronunciation, that's the best I can do, which includes at least 100,000 galaxies. Laniakea is Hawaiian for immense heaven. So we used to think we were part of the Virgo supercluster, but in fact Virgo is just one part of Laniakea. For scale, Laniakea is about 100 million light years across. And interestingly, the Milky Way is right at one end, right at one edge of Laniakea. I don't think there's any significance in that. It just happens to be where we are. So everything is moving towards an area called the Great Attractor. This area, unfortunately, is largely obscured by dust in the galaxies of Laniakea itself. So no one knows exactly what it is. That's a news item for another day, I think. But, I mean, it's likely just to be a much denser part of the universe. But it is interesting that everything is moving that way. So here's the last slide. So they can look further out still and discover that Laniakea is just one of many of these superclusters, and about half a dozen of them have been mapped. This is the Perseus Pisces supercluster shown in red. And as I say, they found about half a dozen. The superclusters of galaxies are all moving in similar ways to Laniakea. They all have these strings of galaxies moving in this pattern. And it's difficult to get your mind around this. So here we are, let's think about Laniakea itself. There's all these galaxies moving in these strings towards an attractor. But yet, at the same time, they're part of the expanding universe. So although they're all moving in this like combined structure, they're also moving apart. And the local group is bound to us. We're never going to lose those galaxies and the matter in those galaxies, but we will lose the rest. It'll all get further and further away. So it's currently in this big traveling group of galaxies, but it's actually also going to sort of evaporate and disperse over many, many billions of years. I don't know about you, but I find all that fascinating. And that is the news.
Thank you. Antonio is going to come up and he's going to do the astrophotography part of our meeting. So just give us a second to get that sorted and then we'll be on the way.
Hello everyone. Sorry for the technical delay. I'm Antonio Filippe. As been said before, representing the part of the committee that works a lot on imaging and the people that have been involved in imaging. Before we move on though, I'm not sure if there's any space later, but we've just finished the AGM. I think it's really, we should really thank Sean for all the work, and he's going to be deputy chairman, and I'm sure he will be helping driving everything for many years ago to go. But I think, Sean, we should really thank you for all the work. And Mark the moment, because it is although we are very happy to have Deborah taking on the role, it's also a bit of a loss to have you in any form of diminished involvement, because I wouldn't be here, many of us wouldn't be here without your work. So, thank you. Now, astrophotography. Who are we? What do we do? Astrophotography, we are quite an active group. There's, as of today, 23 people in the WhatsApp group we run. It ranges from people that just started and come up just to see what we do, to people that have been doing it for years, and you'll see the amazing pictures they get out of that. Everybody's welcome. We are a merry group of boys and girls that enjoy being out there and taking pictures in whatever form. Everyone, I repeat, is welcome. If you want to come along, if you want to just follow our WhatsApp and see what we do, if you want to learn, if you have questions, come and see me later, I can add you. It's really a fantastic hobby and a subset of astronomy that is really worth pursuing. As a personal note, the presentation today, we started with Gaia. Gaia I use daily Gaia as a database to analyze the pictures we take and make the best out of the colors in the picture, make sure that we have the right representation when we develop the picture in a more scientific way. Then we talked about the news about galaxies and the likes, and one of my favorite pictures is, and we'll see a few, galaxies in the Virgo cluster. And you know, my education, I was a quantum physicist, and coming back to this and imaging, because it's fantastic to bring together the creative parts and something beautiful with the scientific part. So there's a bit of for everybody, basically. That's the message in astrophotography. So you're all welcome to join us. We are out there practically every clear night that we can find. Some of us are there more, like me, and others just join when it's needed. But we're also every day on WhatsApp, so feel free to join us. Or follow what we do on SWHAS Astronomy in Instagram, which is a fantastic source for seeing beautiful astronomy pictures. There's a lot of junk on Instagram, but if you focus on what you care, you can find something really amazing. And not to forget, all of this was kickstarted 2 or 3 years ago when I joined, thanks to the legacy from Bob Gardner, and that should also be remembered. So let's move on to pictures. We have quite a few. Ronnie, are you here? Let's see, Ronnie. Do you want to say something about your picture? You have a microphone coming?
Yes. Yeah. Thanks. So I'm a complete beginner. Only started recently, and just wanted to thank Antonio, Andy, and Ben in particular for starting me on this journey. This is really my first successful attempt at any astrophotography, and I'm really enjoying the experience. I'm looking forward to spending a lot more money thanks to Antonio's guidance. He's offered me his credit card, which I'm very grateful for, and getting to sort of some of the images that the other guys post on WhatsApp. It's a lot of fun, and if we had more clear nights, I'd probably be there every night. So many thanks to you guys for helping me through this. You're welcome
we will progress together. You are all learning. Okay, so that was one picture from Ronnie. Then we have one, I think is his first picture from Andrew. You don't see Andrew here. Are you there? Anything you want to say, or shall I do it?
This image was, the processed image is the result of capturing about 230-second exposures of the M3 globular cluster earlier this month. It was taken using a William Optics refractor with an ASI 533 Pro Color camera and an AM3 harmonic drive equatorial mount. It was all controlled on an iPad connected using an ASI Air, which I think quite a few of us are now using, and again thanks to Antonio's persuasion of all, we've all resulted in investing in these things. I really can't take the credit for the post-processing. I would like to thank Antonio for his help and expertise in that part. I think in this image I was just excited to see so many blue stars as well as the older, cooler red stars. I find whenever I sort of do any of this imaging, I start looking up and researching and trying to understand, what it is about that particular target. And I think this one I think it's on like 500,000 stars, which are moving towards us at a speed of 147 kilometers per second. I thought it was quite fascinating. But yeah, thanks Tony for doing the post-processing. Thanks.
Thank you, Andrew. So let me have a few pictures from Andy panel. I'll introduce them, although he's in the room and he's probably being a bit shy because he's an accomplished photographer now. In those days where the moon is out or it's easier to get a camera out, some of us went for star trails this year, and you can see here this is done with a normal reflex camera on a tripod by Andrew, pointing at the northern star and leaving it open for the equivalent of, I can't do the math very fast, about an hour of exposures to follow the trading. We also have some deep sky images from Andrew. In here he's using a much bigger tube, a Skywatcher 200p, which is something this size, on a Skywatcher mount, like 5 or something, and the 6 as well sometime. Again, the principle here is long exposures and a lot of them, and then you put them all together mathematically on the computer later on. We have the Orion Nebula. We'll see a few of these. It's one of the best and nicest target to take, and everybody has a different take on it as well. So that's where the creativity comes in. Although you try to be scientific, there's also choices you need to make in the post-processing. This is quite a detailed picture of the Orion Nebula and the surrounding, taken with the same equipment as before, but a smaller scope for wider imaging. In here, we have the Pleiades from Andrew. Again, small scope, 50 millimeter aperture, Skywatcher. Can you hear me all right? Something's changed. Again, 2.5 hours of exposures to get all the nebulosity of the nebula, which is a dust reflecting nebula around the stars. So you see quite a lot of objects here that are red or blue, and typically red is hydrogen and blue is oxygen. They are emitting light, so much easier to capture. This is blue, but is not one of those. This is a reflecting nebula of dust that shows blue because the stars in the nebula are blue. So much fainter, much harder to capture, especially when there's light pollution. Again, spectacular variety from Andrew. In here you have Jupiter in one single 60 seconds image. Actually, it's a video, 60 seconds. Then you choose the frames that are better for coming up with an image. I think there's 2 of the moons there. I know by memory Europa and Io. And not really recognize them, I just read his notes. And then if we can make it, we will show you this fantastic videos done, which is basically 26 of those 60 seconds video put in one after the other to show the rotation. Because one of the challenges of imaging Jupiter is it turns quite fast. So if you want long exposure, you'll end up blurring everything. But you then get the bonus of having being able to show the rotation by stacking and then aligning the different pictures. Another star trail from Andrew with the fabulous windmill from Cobstone. And all the colors of the stars, I think is fascinating to see all the color coming out. And the Pinwheel Galaxy, another big, bold target. It's been imaged with normal filter, with no filter essentially, where you get all the light, and then with the Ultimate filter, which is a specialist filter that only lets through the ionized hydrogen, so you can highlight the nebulae inside the galaxy. Our imaging from our backyard has got so good that we can see the details of nebulae or even supernova in other galaxies, not in our own, so much, much further away. Now we switch to Thomas. Thomas, do you want to present them or shall I do it?
Again.
Shall I go on?
Yeah.
Hello. Well, when I first got an astro camera and I couldn't get focus on it, I thought there must be something wrong with the camera. It can't be me. And I went to an astro thing in London, and I seen Peter Rees, and he told me about here. I didn't even know it existed, you know. So I joined, and I talked to Sean, and he said that they would make a project, make sure that I could get focused and get pictures taken. And I thought, well, that's a big ask, but they did. And thanks to Antonio, Ben, Andy, everybody helped so much, you know, and everybody knows a little bit of something else. And finally I managed to get focus. That's the Heart and Soul Nebula, you know, and that's from my front door at Borto 6. My wife worries because if I go out in the middle of the night, nowhere, like all alone, she worries. I don't know if she worries about me or my equipment, you know. But anyway, the good thing about going to High Top is there's a group of people there, and she's happy she can sleep that I'm up there and it's safe, you know. So I've got to thank everybody for all the help, and hopefully I can pass it on if I learn more to new people coming along. So thanks everybody.
It's been a pleasure having you around. Yeah, there's a lot of jokes I can make about coming back at 4 o'clock in the morning with, for example, the second seat in my car completely flat, and my wife, trust me, knows that I'm putting the telescope there very carefully. So, shall I go on with your pictures then, Thomas? Yeah. Okay. So this is actually, I have to say the projector is pretty bad because you barely see it, but it's more visible on a normal screen. In here, there's the Horsehead Nebula. I'm not sure. It's a shame because I can see here the difference between the projector and the screen, but it's quite visible on the screen. It's a very difficult target because it's very faint, and the Horsehead is in the Orion constellation, and is a tiny target, and is essentially all the red you see is emission hydrogen, sending out light in the red, and there's this dust nebula in front that has the shape of the Horsehead, but it's quite faint. We were talking about the Virgo cluster. Right in the middle of the Virgo cluster, not necessarily the supercluster, but the classic Virgo cluster, we have this beautiful target called the Markarian chain, and you can start counting the galaxies here, 1, 2, 3, 4, 5, you move on, and some of them even interacting here. I think, as most of the pictures, Thomas took them from London, or outer skirt of London, or London, and so it's quite an achievement to be able to see all of the chain in one image. And then this is also his take on the Pleiades from before, where you start seeing some of the nebulosity. Again, it depends where you're located, the light pollution, and how long you can give to the exposure time. Beautiful, again, way more visible on the screen, view of the Milky Way behind Wilton Windmill. So as you can see, there's a variety of things you can do. You don't need a telescope to take images. Come along, and some of us, not me, but are quite adept at using DSLR cameras on a tripod. Moving on to pictures from Russell. Russell, do you want to present them? No, he Shall I go on? Again, very nice and clear picture of Jupiter and Callisto there. Again, taken with the principle of taking videos and putting them together. Unfortunately, your great notes are not visible on my screen here, so tell me if I forgot something. And then we have M3, again, similar to what we have seen with Andrew. You can see the different colors of cooler red stars and typically younger, brighter stars in blue. So you can start counting if you want, but there's quite a lot of them. Beautiful picture. And then another winter favorite, M81, the Bode's Galaxy, and M82, Cigar Galaxy, both in one picture because they're quite near each other, they're interacting with each other. That's why the Cigar Galaxy has that strange shape and all the hydrogen ionized jets coming out, because it's basically being torn apart by the nearby galaxies. And again, you can see some detail and some nebulas, maybe not so good on the screen here, within Bode's Galaxy. And you've seen that before, but it's quite an achievement to have a partial solar eclipse and a Ryanair flight FR7949 passing by. I don't know how you worked out that exactly that, but probably it's possible. Well done. Is one of those pictures that everybody wants to have, that striker flag, that you have something to show. Now, Stephen, do you want to present them? Are you sure? Because when I say there's some professionals among us, I don't think I'll do justice to the variety of the pictures you'll see from Stephen. But this is a 7 frames collage of the sun taken with a Lund 80, which is a beast of telescope dedicated to solar. It's basically the bigger brother than the one we have with the Society, and that I use at outreach events sometime. And on top of that, he has a Quark Chrono, which is another piece that gives you even more insight into the sun. But you can see the detail, you can see the surface, you can see, as you maybe know, this year marks probably the highest point in a 11-year cycle that the sun is going through. And so there's a lot of interesting stuff to be seen. This is all taken with a mono camera. They're more sensitive, they're more detailed, they have a smaller pixel, so you can get the best out of the image and this fantastic telescope. But, you know, kudos to Stephen for this picture, because it's quite making us all envious. And this makes us even more envious. I mean, the detail and the numbers of stars in this image is staggering. This is M13, the globular cluster in Hercules. It's one of the big targets that you can even see with binoculars. But when you have astrophotography kits and you know how to use it like he does, then you see the majestic, you know, grandiosity of the target. This is 2 minutes exposure, 120 of them, so that makes 4 hours basically of work to take this image. And then another spectacular image, especially because of the nebulosity and the extension of this target here, the Sunflower Galaxy. It's going by memory somewhere between Coma Berenice and the Ursa Major, so quite visible over winter. But it's a small galaxy, and seeing that detail, you need a decent telescope like the Celestron HD8, which has a focal length, I think, about 2 meters, folded in a Schmidt-Cassegrain configuration. I have the smaller brother, and I tell you, I don't get these kind of images. And then a fantastic camera, the ZW2600 MC Air, which combines the computer and the camera and everything you need in one very powerful pack. Again, doing numbers quickly, an hour and a half or an hour and 40 minutes of exposures, if I'm doing it properly. Sorry, 3.5. And even more beautiful, same telescope, same zoomed in view. This is the core of what we know as the Rosette Nebula. If you look at it from afar, it looks like a rose, but in here you can see the detail of the star formation area. Unfortunately, again, if you saw it in a decent screen, the colors are so much more wonderful and the detail is more wonderful. I'm sorry that we, you know, but I send you back to Instagram where you can see them in full beauty, although on a small screen. So, again, another majestic picture from Stephen. I think we now, we have one more, again, looking better here. But this is the detail of M82, the Cigar Galaxy. And I tell you, especially from anywhere near southern England and London, getting that kind of detail on the jets that come out perpendicular to the galaxy is quite an achievement. Doing it so zoomed in with a telescope like the C11, which is quite temperamental and complex to use, it's really an achievement. Okay, now we have a series of pictures that taken with the exact opposite of the equipment you heard about so far. This is the tiny little beauty called the C-Star. Is a machine you can buy for £400, £500, depending on the version. And it does virtually everything for you. And so it's a fantastic way to learn, to start. It's powerful enough that you can download the pictures and process them separately on your own. The following pictures, and this picture was taken by Suzanne. Suzanne, do you want me to talk about them or do you prefer? Come along. Come along.
Cool. So this image of my sea star is taken at Hardy's Monument. Oh, hello. Sorry, I've not used a microphone for a while. It's at Hardy's Monument in Dorset, if ever any of you have been up there. Sorry, yeah, next one. This one was taken at home in Hemel, or it was taken up at the observatory. I can't remember which one it was. but it was a case of find the moon, point at it and see what I can get.
Clicking too fast.
Clicking too fast. Oh, okay, sorry, next one. Okay. Don't know why it was that way up. But that's as you can clearly see, that's the Andromeda Galaxy, and I took that one to I did a presentation at Canberra Club, Watford Canberra Club, and I discovered this group by going to that group, and Peter Rees is in that group as well, and one conversation led to another which led me joining here. And I did the presentation, kind of got roped into doing that, but thoroughly loved it, really enjoyed it, and I put this image up, and I got lots of oohs and ahs. So I was very tough with it. I know there's a streak right through the middle of it, so I have no idea whether that's an aeroplane or a satellite, but I'm not really bothered. And that's my idea of processing, because I just mess about with the sliders on the computer, so my post-processing is not that great. But
and I have to say again, I refer you back to Instagram when I start posting these things, because it looks so much better on the screen than
it
on
does.
the projector.
It looks a lot better on here than it does up there.
Yeah, there's more detail, there's more... Okay.
Oh, that's good. Glad that looks good.
Okay, so on the recording you'll see all the pictures in all their beautiful glory.
Yeah, and also what I like about the Sea Star is it tells you where I was and how long I exposed it for, what it was, and the camera club were going like, what's the M stand for? And I was like, okay, fine. M stands for Messier, astronomer, 1771, etc., and how far away the asteroid bodies are, which I really enjoyed that. This was at the parsolar eclipse, and there is another set of spots on there, but can't quite see them because the moon's moved in and then the moon moves out. Yep. Cool. Another shot of the moon came out, lovely, stuck it up, and I discovered the Sea Star at the Christmas meeting, so it was Phil, I think, yep, thank you, and I went and bought this in January, and I absolutely love the thing. I took it on holiday to Dorchester, and most evenings when it's dark, this thing comes out. The Sea Star, not the moon, sorry. Yep, and the Orion Nebula, which was actually quite funny, because when I was at Canberra Club and I said, oh yes, this is the Orion Nebula M42, one of the chaps went, oh yeah, is that in the Big Dipper? No. Oh no, yeah, is that the plough? No, not the plough. And then a bit later, two of the images popped up of the Orion and the plough, and I went, it's this one, not that one. But they were enthralled by the end of it. I didn't even get a chance to say, any questions? Because they were just throwing questions at me left, right and centre throughout the whole of my talk, which I was really pleased about. But they all really liked my images. Sorry, next one.
I think we're done with yours.
Yep, I think I'm done.
Okay,
Lovely, thank you all. I'll try not to fall. Thank you very much. Cool. Again, I'll try not to fall down the stairs. If I do, I'll try and get around.
Right, Phil, if you want to talk through your images, you're welcome. I lost the notes, unfortunately, that were on the computer, but otherwise I'll talk through them. You're happy to? Okay, so basically this is also another spectacular picture taken with the Sea Star. So the Sea Star is capable of doing normal imaging, and then it comes with a filter, is a white light filter that lets through, diminishes the intensity of the light, but lets through the whole spectrum, unlike the telescope pictures done by Stephen that were really focusing on a very narrow band of hydrogen alpha to show the detail of the surface. But with something as simple as the Sea Star, you can see and track and do even science basically by tracking the marks on the sun. And so it's quite an achievement for such a small thing. In here, the Pelican Nebula, again, slightly better off on the screen. Difficult target, very faint, it requires many, many hours. It can be achieved with about 50 minutes, as you can see, of Sea Star exposures. It's in the Milky Way, it's typically a very good target for the summer, where you have all the nebula season. I don't know, many of you probably know, but we're just coming out from galaxy season, where at night we look outside from our galaxy into the deep cosmos, and so we see the other galaxies. And then from about June to December, we have nebula season, where at night we tend to look towards our own galaxy and see all the nebulas and the beautiful, colorful things that are in there. And then this is another take from Phil on the Orion Nebula, 60 minutes with the sea star, definitely better on the screen, but a nice picture. And this is quite zoomed in, actually. This is one detail of the Merope Nebula, which is part of the complex reflection nebula around the Pleiades that I was mentioning earlier. So it's still amazing that someone, using that kind of equipment nowadays can take this detail-focused, very spectacular picture like this one, where you can see the Orsed in all its glory and the surrounding nebulas from hydrogen emission. And it's a difficult target in any telescope, because that star, the name escapes me right now, but is one of the 3 stars of the Orion belt, is extremely bright and burns through basically any camera you point at it. Exactly, the experts come to our rescue. Right, I think the next is me. I wanted also to show you the equipment, because we talk about telescopes a lot. How am I doing with time? Do you have another 5 minutes? So this is a typical configuration, although my one is a bit exotic because I have the camera in front, but it's a C6, a normal Celestron SCT. It's been modified with a lens at the front, which makes it a very short focal length, which makes it much, much faster. It's an f2, so it collects light about 9 times faster than your typical refractor telescope. So it's a beast for nebulas and wide, big target. And then you have a control unit here, which is typically what most of us use here. It's an integrated solution that you control with your tablet. A moving robotic mount that allows you to find things in the sky and track them very carefully. And then a mini telescope of some sort that allows you to fix a star in the sky and track it, so you correct the mount every second or 2 to make sure you're tracking. And it means that then you can take 3, 5, 10 minutes exposures without star trailing, and then you can really bring out all the detail of the pictures. So with that telescope, which as I said is really good for big targets, typically summer and autumn targets, this is my take on the Pleiades, where I say only, but there's about 6 hours or something there, I can do math that fast, of exposure. It was taken in Italy, up in the mountains on 1,200 meters high, clear sky, bears country. I spent the whole night there stranded with my battery flat. It's not pleasant. Wolves and bears. You really don't want to go anywhere far from the car. But this is also taken in Italy. This is again my take on the Orion Nebula. I need to reprocess this one. It's been a little bit overexposed in the center. But again, it's about 4 hours in mono. So I take pictures with a mono camera with filters in front that take hydrogen only and then oxygen only, and then I put them together. So this is only what the nebula emits in hydrogen and oxygen. No other colors, no dust, no reflections, just those colors. And then this is the Society's solar scope. It's a Lund 50. It's fantastic for seeing the surface of the sun visually, and also to take images similar to a degree to what Stephen has shown us before. With that one, I went out and imaged the partial solar eclipse during the event, and also we showed it to people passing by. They were quite surprised. You could see the surface, or what is more or less the surface of the sun. It's not very scientifically correct to say it's the surface, but the chronosphere, I think. But essentially, you take a short video and you select the best frames within that video, and then you stack them with some kind of software, which is, by the way, free, so it's very accessible once you have the telescope. And then you can see much more detail around the sun. Again, better on the original picture. And then your more classic refractor with the similar mount and camera mounted on top. This is for mid-sized targets. And this winter I had a lot of fun. This is the Leo triplet. So there are 3 galaxies clustered together, essentially under the belly of the lion, if you know what I mean, the constellation. They interact with each other. The one at the top there is called the hamburger galaxy, popularly, so quite recognizable for that. And then my next picture is again M81 and M82. This is 11 hours of exposures from London, so light polluted areas, the telescope I showed you earlier. But within 11 hours, you start seeing, I have a pointer somewhere, but you start seeing the nebulosities that is called the intergalactic medium. This picture needs fixing a little bit, but it starts being visible outside the galaxy. There's a nebulosity and powders, basically dust. But what I like about this picture is that there's so much detail in the camera I'm using that if you zoom in, this is what you get. You get the full detail on M82, the intergalactic medium, and all the different nebulas inside another galaxy are clearly visible in detail. And I think we are done for the night. We'll probably do another session in December as we normally do, but I really welcome anybody to join us and make the group even bigger. We're probably the largest astrophotography group in the country. I would be surprised if we are not, so let's make it even better. Thank you.
Okay. Thank you very much, Antonio. That's brilliant. I do realize we skipped the any other business, so I'm just going to open that for a moment. The any other business is where if you've got a comment to make, you want to say something, you think something we should be doing in the society, etc. So if you want to have any other business, please raise your hand and we'll get a microphone down to you. Thomas? Okay. Well, thanks for that. It's nice to hear the feedback and that things are beginning to work for the astrophotography group. Good. Anyone else got any comments to make or anything that we should be doing or not doing or whatever? No? Okay. Well, thanks for that and thank you for attending. The AGMs are never something that attracts a lot of members. But thank you for coming along and supporting us, and refreshments are now being served, so thank you and have a good evening.